Hello students with Dr. Wesselman's class and anyone else who wants to have a little design lesson here. I am at the National Zoo in Washington, D.C. and I've come across this setup here of a square table and 4 chairs. This is set up really interesting design which can give you some ideas of design and a review of multiplication and how you might use the design features to do all of your arithmetic operations. On the square table here, there are a total of 23 little holes each this side, and this side, and this side, and this side. 23. Very interesting that it's an odd number, but it is. And in fact, everything in this whole display is basically set up on odd numbers. Look at the chairs. There are 1, 2, 3, 4, 5, 6, 7 across each chair. And then now we have 4 down, so you can see 7 times 4, 28. And in the base of the chair is also 7. 1, 2, 3, 4, 5, 6, 7. And down is 1, 2, 3, 4, 5, 6. So you have 7 times 6. Everything in here has both an even, but it's really the odd design of 7 or 23 that is rather intriguing. Now, you can also then try and estimate how many holes overall would there be here. And part of the thing is you can't just say, oh, it's 23 by 23. No, because look inside the design here, it gets down to 3, 3, 3, and 3. So it's actually taking this progression of the design of 23, and then you can look, and we'll take a really good picture of it, how it goes down, and how does it reduce down on these angular pieces. See, the angles play a very major demarcation in through here. So you can divide by 4 easily because there's this chunk, 3rd chunk, and 4th chunk. So this gives you nice division. You could even say what proportion of all the holes is in this one side here. Well, it should be a quarter because they should be all the same, but maybe there's a surprise. Maybe the geometry doesn't hold as well as we'd like. So you need to think about how you might estimate, how you might come up with the proportion, how could you do the division, and how you can actually talk about what percent are in each place. Because that's where, when I taught adults or I had to teach teachers, percentages are misunderstood so often. You cannot add percentages, right? And if you're going to add fractions, you have to make them common before you do that. And we don't really ever use common fractions otherwise, but you need to know what the denominator is. And as you forget the denominator on your percentages, you don't know based on how much information it is. It's very important to know the difference between 6 out of 8, 3 out of 4, 75%, and 0.75. You can say they're equivalent, but they have different actual valuable meanings. 6 out of 8 says the denominator is 8. 3 out of 4 can be an equivalent, but it tells you less about what the data was based on. So you want to always record the denominator, and that's where I see adults all the time when I had my research firm make mistakes on the denominator. You need to record. It's like how much survey you had, how much data did you have. That is the denominator, and then how many people said yes. Don't just tell me it's 66%. Don't just tell me it's 32%. Tell me how many people responded. Tell me the ratio, then I can calculate it as a percent. For comparison over time, perhaps, but you can't add percentages, all right? They are ratios. All right, so here's this wonderful table, and it has this great design based on 7 and then based on 23. And what do you know about 23? Is it a prime number? Is 7 a prime number? I'll just leave those questions. So this is what I'll call a prime table figure. All right, this is the numbers lady. This is a little class for Dr. Wesselman's Math and Science middle school class. Bye-bye.